Hello, welcome to FX PhD. My name is Matt Leonard and this is arn201 Real World Lighting and Rendering class number 3. So in this class we are looking at lighting, and as always we've got quite a lot to get through this week. We're going to start by having a look at supported lights. We're going to then move into some of the common light attributes that you'll find in many of the lights that we'll be using with Arnold. Then we'll go ahead and we'll look at some specific Arnold lights, things like the area light, Skydo, mesh, etc. And then we'll finish up the class hopefully with some time to look at light filters. So let's begin by just having a look at some of the supported lights. Well, Arnold supports pretty much all the lights you might possibly want. So we have support for direct, point, spot, cylindrical, disc, quad, photometric and mesh lights. So a whole selection of different lights can be used inside of Arnold. Some of them are obviously Maya lights, some of them will be specific Arnold lights. But with Arnold, all of our lights will suddenly have an Arnold tab attached to them, and that would be where we can make specific changes for the light that relate directly into Arnold. But we'll have a look at that in a moment. Let's now have a look at some of those common attributes. So we'll begin by just picking a normal light such as a point light. So over here in Maya we're just going to come to create light and we're just going to grab a point light. We could also come to the Arnold menu, lights, and choose a Maya point light from here. Pretty much makes the same thing. So I'm just going to take my light, I'm going to lift it up and I'm going to move it out in front here. So if we were now just to hit the render button, we'll see that we should now have some illumination in our scene from that point light. Okay, so that's rendered through. Took about 51 seconds. So let's just go back and have a look at our render settings. So I've got my diffuse glossy down at 1, refraction and subsurface scattering I've put to 0 because we don't have any of that in our scene this week. So I'm going to just take the camera AAs down to 3, and then you can also see for the ray depth we have diffuse, glossy and reflection set to 2, refraction at 0 and transparency depth at 0 as well, as we have nothing translucent. So I'm just going to go with that, and let's now move across to look at some of these common attributes in our point light. So we come to our point light shape, and you'll see in here we have an Arnold section that we can open up. If we just drop this down and maybe close some of these tabs just to make things a little bit easier. So I'm going to lose the help bar, keep the command line, range, time slider, and I'm going to lose the shelf as well this week just to give us some extra thinking room. Okay, so back here we can see we have our Arnold tab and some of the common attributes we have. Firstly, we have this use color temperature. So once we switch this on, what we're actually able to then do is dial in various degree Kelvin temperatures, and it gives you a nice little look here as to what you're getting. So something like 1000 is quite a cool color, and so that's going to give us quite a red, bright, kind of reddish orangey color. So I'm going to come in and I'm just going to turn my intensity up. This wouldn't be normally the way that I would work, but just so we don't jump too far ahead in the class, I'm just going to use the traditional intensity, and I'm going to pop on my IPR. So you can see immediately we have a very kind of reddy orangey color. I'm going to continue to increase my intensity maybe to 10 or even 15, just so we can really see what's going on. Now, if we continue to come back to our color temperature and raise up this value, if we wanted to go more orange, we could go with a degrees Kelvin of say 2000. You can see we're now getting a very orangey look. If you wanted to go something that's a little bit more kind of daylighty, you could go with 5500. You can see we're getting a more kind of natural look almost. The whites are pretty much white now. If we wanted to carry on and begin to get into some more blue colors, we could look at a temperature such as 7500. and that's going to really add quite a lot of blue to our image. And then if we went up to something like 20,000 degrees Kelvin, we're going to end up with a very, very blue look. So the extremes would be 20,000, and then in the other way, 1,000 is going to give us the very reddish orangey colour. So somewhere around 6,500 is quite a good number. And you can see here I've just thrown up a chart that just shows you some of the kind of values that you might be looking to use for different scenarios. So for something like our view, we may be interested in maybe something like a tungsten 5K light. So let's go with a value of 3380 for our degrees Kelvin, and we get quite a warm, nice light. And this is kind of based on the colours being more outdoorsy. Okay, so that's looking quite nice. Below that, we then have our decay type. Now the decay type isn't available for our directional, distant or sky dome lights. So they're the lights where you're not going to see this, but for all our other lights we've got support. And basically we've got two types of decay. We've got quadratic, which uses inverse squared decay, and then we have the constant, which basically just means that the light never falls off. So if I put it onto constant decay, you can see immediately everything looks very bright and quite garish. And this is because the light that we have in our scene now, it has no fall off whatsoever, and it's very unrealistic, not physically correct. When we put it on quadratic, we now get that really nice inverse squared decay, and we're getting a really nice look. Now below fall off, we have exposure, and exposure is really more of a kind of an f-stop value. So let's come back and switch our intensity down to 1. This would be the way that you're really going to want to work. And everything you want to do with brightness, you want to use this exposure value. So exposure basically is multiples of intensity by 2 to the power of the f-stop. So if we increase the exposure by 1, we double the amount of light. So we crank that up, we've now doubled the amount of light. And in Arnold, the total intensity of light is computed in the following formula. It's basically colour times the intensity times 2 to the power of the exposure. Okay, so that's the way you want to think about it. So if we're going to put our exposure up to say 2, we're again going to be doubling the light, and so it's going to get 4 times brighter. So this is really what we want to use with regards to increasing the brightness of our lights. So again, if I went to say 4, we've then gone up quite a dramatic amount, and I could go up again maybe to 8, and I think we're going to find that's way too bright. So let's see what 6 gives us. 6 still feels a little bit too peachy for me, so I'm going to return to 4 for the time being, or maybe 5. 5 is a nice intermediate value. Now next up we have samples, and these samples control the quality of the noise in the soft shadows and direct specular highlights. Now the higher the number of samples, obviously the lower the noise, but the longer it's going to take to actually do the rendering. Now firstly, it's worth noting that if you put these samples to 0, it basically disables the light, so you're always going to want to have that at 1. What we're then going to do is we're just going to take this radius, and I'm just going to increase it to say 1. Now what that's obviously done is it's made our shadows soft. So let's talk about radius very quickly before we get into talking about the actual samples themselves. So what the radius is doing is actually giving the light a physical size. So if I was to, for instance, to make it 0.1, you can see that we're now beginning to get some slight soft edge shadows, just because the size of the light is no longer kind of infinitely small. It's now actually physically 0.1 units in size. If we wanted the light to be softer, we could then increase that again to maybe 0.2. And you can see now we're having again softer edges. So let's just draw a region of interest around, say, here. And let's just do a straight render of that, now we know what radius is doing, and let's see what we're going to get with a single sample of information. Now remember, just like last week, these samples are squared, so 1 squared is obviously 1, but when we put it to 2 it will become 4, and etc. And this again is times by the AA, so that's another thing just to be aware of. So having rendered the whole scene, you can see that we're getting quite a lot of noise now in this area around here. So we'll just let it finish, and then we'll be able to find one of the softer areas and just be aware of what the noise is doing. Okay, so I'm going to grab not over here as I was going to, but maybe in this area here. So I'm going to save my image, and let's now increase the samples from 1 to 2, which is obviously giving us a ray count of 4, and again do just a regional render this time. You can see between the two we're actually getting a little bit better shadows, especially on this fine edge here. You can really see the difference. So again, if we increase this to say 4 squared is obviously 16. Again, I'm just going to save that and do another region render just so we can see what that's going to be looking like. And again, if we just go back and forth, you can see again we've added quite a lot of smoothness into those. So I'm wondering whether 3 is going to be a good amount. That might be perfect for what we need. Now, just so we can see what all the shadows look like at this setting, I'm just going to again do a render of that. Okay, so that's finished rendering. You can see we're now getting a really nice result. A lot of those shadows are looking very nice. The little bit of noise that you might be seeing here is actually probably in the diffuse sample, so they would probably need to be increased a little bit. Okay, but for the time being we'll just leave that as is. I'm also going to just take my color, and I'm just going to increase it to a whiter color, maybe 5000 might be a good number, still a bit of warmth in it. So let's move down to talk a little bit more about radius and normalize. Both of these work together in so much as when you have normalize on, the amount of light isn't affected by the size of the radius. And this enables you to basically increase the softness of your lights or the softness of the shadows without having more light come into play. So let me show you what I mean by that. Let me just come in and switch over to IPR. So this is what the scene looks like with normalize on. And I'm going to turn my radius down to 0. Okay, so we've now got hard edge shadows because we've got no size to the light. I'm now going to switch off normalize, and I'm going to just make sure the IPR is just refreshed, and you can see this is what we're getting. It looks pretty much the same. But as I now increase the size, let's go to 0.5, we're physically making the light size bigger, and so more light is now going to be emitted. So not much change there. Let's go to radius of 2. You can see with 2 we're having a huge difference. Much softer edge shadows, but the whole size of the light now is physically larger, and so we're emitting more light out of that area. If I go to 1, you can see that's still pretty bright, and we're obviously going to be getting those physically accurate shadows based on the size of the light and the amount of light being emitted. So let's go back to 0.5, and if I now turn off normalize, it's just going to set the amount of light based on a more artistic choice. So what I'm going to do is I'm actually going to turn normalize off, because we want the size of the light and the shadows and the amount of light coming out to be pretty much all as physically accurate as we can. Now next up we have shadow casting, or rather cast shadows. This is obviously very clear. Switch it off, all your shadows disappear. Switch it on, they come back. If you adjust the shadow density, which we shouldn't do, because if we do we're going to be breaking the physical accuracy of our lights, you can basically dial the shadow down so you're making it less dense. So if we went with something like 0.25, our shadows will still be there, but they're going to be very soft. Okay, so I'm just going to put it back to 1. Then we have some controls here for affecting the volumetrics and casting volumetric shadows. So first off, affect volumetrics. This basically allows the light to affect atmospheric scatter and fog. So distance lights aren't supported, but everything else is. So let's just do a quick setup of setting up some fog and atmospheric scattering. Okay, so I've set it up and I've done it very quickly. I'm just going to show you what I did, and we're going to obviously cover this in more detail in other classes. So I basically came down to environment and I clicked in the atmospherics and I chose volume scattering. What I did in here was basically choose the color, the attenuation color if I wanted that. So I might have a little bit of attenuation, and maybe it attenuates off into, say, a kind of a darker blue color. So we can attenuate off something like that perhaps. And then in the density here, I've just added a Arnold noise. So if I now re-render this, you'll be able to see, again, come back to the point light, what it looks like with the effect of volumetrics on. And again, I'm just going to turn down my AAs just because this will take a little bit of time. So we're going to have pretty kind of atmospheric environment all over our image. I've also just adjusted the temperature up a little bit into a more bluey color, 6500, just to make it a little bit more atmospheric. But you can see that's what we're getting. Now it's worth noting that we also introduced the samples for this volume scattering at this point as well. So I'll just show you where that was in case you missed it. So if we just come across to here again, close that down, you can see here you've got samples again. So I might just turn those down to maybe 3 just to speed things up. But you can really now see what this volume scattering is doing. If I just come back across and turn off affect volumetrics and render again, or just render maybe this section, be able to see what's happening now with those volumetrics not being affected by the light. Okay, so quite a dramatic difference in what we're getting. Now we also have cast volumetric shadows, and as you can imagine, what this basically does is it determines if volume shadows are computed. Okay, and this isn't supported for ambient, distant or sky dome lights. So if we leave that on, and I just come back to here, there's the difference with effect volumetrics on and off. But if I put this back on but turn off cast volumetric shadows and just render that again, we'll be able to A/B between the cast volume shadows on and off. Okay, so that's finished rendering, and the area to look for is down here, this kind of area. Do you see how we're getting that change in the way the shadow is being produced, basically disappearing when we have the cast volumetric shadows off? Okay, so I'm just going to come back to my render settings, and I'm going to come to atmosphere, and in fact I'm just going to select it here, select it and just delete it, so that's gone. So we should now be back to our normal scene. Now what you would have noticed was a bit further down there's also volume samples. Once our attribute editor loads up again, this volume samples basically affects the samples for the volume information. So if you have it down at 1, you're potentially going to get some noise in there, and as you increase that, remembering it's squared and times by the AA, you're then going to get nicer volumes in your lights and shadows and things. Now next up we have this section here, which is the diffuse specular subsurface scattering, indirect and maximum bounces. All these obviously fit together. This is basically a per light scale for all of these attributes, and it basically scales the light contribution to all of these areas. So for instance, if we were to take down specular, so I'll save this image, let's take down our specular contribution to 0.25. Well, obviously now we're only going to get 1/4 the amount of specular contribution to the scene. So if I re-render it, and then we do an AB again, you'll be able to see the difference in just taking that weight down to such a small degree. And already here in the top of his head, you can really see that all that detail that was in there has been quite dramatically reduced. Okay, so you can see it's definitely quite a big change. Okay, so we can stop that. It's pretty clear what that's doing. Again, normally to keep this physically accurate, you're going to want to keep these on, or that's what I'm finding. So then further down, we have this indirect number here. And this basically affects the energy loss or gain of each ray bounce. Normally this would be 1. And really, unless you know what you're doing and want to mess with it, you want to keep it at 1. Bigger values basically make it impossible for the GI algorithms to converge on a stable solution. So for instance, if I was to crank it up to say 1000 and we were to re-render this scene, you're going to see that we're going to get quite a significant difference and quite an unpleasant image. Okay, so again, I'm just going to put this back to 1, which is where it needs to be. You probably don't need to mess with that. Finally, the light bounces basically defines the maximum number of bounces that the light will take. So 999 is just a good value. Make sure it's nice and high and we get all the bounces we want. So from here, let's go across and look at some of the other Arnold lights that are specific to Arnold, having covered all the general attributes. So I'm going to delete the point light. Let's come into Arnold again, lights, and let's have a look at area lights. So this is basically a complete Arnold light. It's not the Maya area light. It's a new area light specific to Arnold. And it has all the controls that we've talked about with a few additional ones. So firstly, we have this light shape. So we could say we want a cylinder, a disc, or a quad. So quad is reasonably straightforward. If we just leave it on quad, and I'm just going to come in, raise it up, and I'm going to look through it so I can position it. So look through selection. Just navigate round. Maybe have it something like that, and come back to my camera. And if we now render the scene on IPR, just so we can see what we're getting, there is our brightness. We have obviously our exposure, which we found last time something up at about 5 was quite a good value. Okay, so now we're getting something quite nice. We've got really soft shadows, because you would expect that from an area light based on the size of the area light. So as we increase it or decrease it, we're going to be getting different amounts of shadows. Now, as before, we have the ability to adjust the number of samples. We can also affect the resolution of the overall size of the image, the overall size of the light. So for instance, I could say that I want a 2K resolution, 2048, and we can then increase that to give us a larger resolution to the light. And we can then obviously put into that area light a specific texture, and this resolution value really needs to be set to the size of that texture map. So if you have a HDR where you've taken out a light and you're going to then apply that to your area light, this resolution needs to be set to that. So let me just give you an example as to how that would work. Okay, so I've quickly just called this image into Photoshop. This is just a high dynamic range image taken from the lobby of a building. I'm just going to focus in on this light up here. So you can see as we adjust it, we've got a whole good amount of information in there. So what I'm going to do is I'm going to come in and I'm going to grab that section. Now obviously this should be undistorted first, but I'm just going to grab it like so. And I'm going to go with something like that. And I just want to grow the selection, modify, expand the selection by maybe 5 pixels to give me that. Copy it, make a new image, and paste it in. and then I'm just going to stretch it into a square. So I'm going to go with 130 for the whole thing. It gives me something like that. Now these corners I'm probably just going to get rid of. So I'm just going to grab a colour from here, go to my brush, B for brush, just paint those out. Then I'm just going to take the whole image and I'm going to make it 256, which is a nice round number. Okay. So that's going to be the map we're going to use in the Arnold area light. I'm just going to now save this out. And this would normally be the way that you would approach doing lighting for something like a physically plausible scene, where you want your lights to be localized as opposed to all set on a sky dome. So I'm just going to come across to week 3 and drop them in here. I'm just going to call this firstly an EXR. It's going to be called Light Example HDR. Save that out. I always tend to use zip compression. I find that works best in Nuke and also works great in Maya. Back to our scene, back to our area light. In the color, I'm going to now load that light. So just click on the swatch. I'm going to come to textures, image, drop in my area light here. So there it is. Up it comes. We've got the ability to do multiplies and offsets if we want to, but I'm just going to leave it as is. I'm just going to return back to Arnold. I'm going to set now this resolution to that value, 256. Just seems to optimize it for what we need. And now I'm going to re-render that scene with the IPR. So you can see now what we're basically getting is that scene illuminated based on that light that we've grabbed. So if I want to, I could now come in and just turn down the actual brightness of that. Okay, so that's now using the quad light with a resolution set to the size of the image driving the light itself. Okay, the other setting that we have is light shape, and here we can basically say we want it to be a quad, as we've been using a disc, which may be more appropriate for the image we're using, or a cylinder. So you're probably familiar with how they work. So I'm going to keep it on quad. I'm going to increase my samples to maybe a sample value of, say, 4. Everything else I'm going to leave the same. Color temperature I'm going to leave off because we're getting that mainly from the light, as long as obviously we're keeping our linear workflow. And let's just do a render of that, just so we can now see that final result using that area light before we move on to have a look at the sky dome. Okay, so now that's rendered, you can see that we're getting a pretty nice image, remembering that our overall AAs are only at 2, so they probably would want to go up, but overall that's looking pretty nice. So I'm just going to save this one out, just so you have it, and I'm going to save it as O2 area. And let's go ahead and now just delete that area light. Next up we have our sky dome. So for this I'm going to take the room and I'm just going to get rid of the walls. Hide those. We can now come to Arnold, Lights and Sky Dome. Now what this does is it makes a sky dome light shape, and we've now got a control that enables you to do all the normal things: color, intensity, resolution, and then some specifics for the sky dome. So let's first of all just do a straight render of this. So I'll do an IPR so you can just see what we're getting quickly. That's what it's looking like. So we've basically just got a big amount of white falling across the scene, and obviously we're getting shadows based off of that. So you've got some nice ambient occlusion around the base of these objects. If we come in and now say we want to actually take an object, take an image and apply it, we just go to the color, we click on the little swatch, and again, as always, we go with a Arnold image. I'm just going to turn this off for the time being. I'm going to come to the image name, and I've got a whole selection of shaders. I'm just going to choose one now and give it to you. So I'm going to go with maybe, I think we've used Puzzlewood before. I'm going to go with a Tintin Abbey cross here. Okay, so we're actually going to be using a cross. We could use a lat long. We could use just a standard kind of spherical ball, but I'm going to go with a cross on this one. Okay, it's slightly unusual, which is why I'm going with it. Now, if you're unfamiliar with what a cross looks like, it's basically a lat long taken apart into like a cross shape. So if you imagine getting a cube and unwrapping it, you're going to end up with that kind of cross shape. So that's what I've got here. Now, in order to deal with the cross, I come to format and I say it's not a lat long, it's not a mirror ball, angular, lat long, or cubic. So we want cubic for this particular one. Exposure we can adjust if we need it, and then obviously samples we're going to increase slightly. Okay, so these are the main things for our sky dome. If I now come ahead and click the render button again, you'll now see that we're going to be getting our illumination based off of this HDR map. Now the resolution, again, I should have changed, which I haven't done, and I need to find out how big my map actually is. So what I'm going to do is I'm just going to stop my render, I'm going to come back to Photoshop, and I'm just going to load that map up so you can see it. So it's this one. I'm just going to load it in. You can see it's 27 megabytes in size. Here's the map. So this is what it's looking like. You can see we've got some really good high dynamic range. If we come in here and just focus in on this section, probably not quite that far. Let's back out a little bit. Pick up our little swatch color picker. You can see here we're getting values of about 0.1. Here we're getting values of between 3 and 7. And then here in the middle, you can see we've got clipped values up to 20. So it's pretty high. Not as high as it could be, but still quite high. So we've got 20. Now the important thing is obviously the resolution. So I'm going to come to image size. You can see the resolution is between 3000 and 4000 pixels. Now obviously it's a rectangular shape, so you need to take that into account. But I'm just going to say that my resolution is 3077. So back to Arnold. Resolution 3077. So that's going to make sure that the resolution that Arnold is working with is the actual resolution of the map itself. So again, we can see this is what we're beginning to get once it's updated itself. The intensity may be a little bit too low. So once Arnold's finished computing what it's doing, we're just going to increase the intensity to maybe 1.5. And let's just go ahead now and render this. Now, while this is processing through, just come down to the bottom and you can see here we have viewport. Now if I open up that, this sky radius basically is the size that the sky will appear in the Maya viewport. So it's important to set that to the size you want. If you're finding it's going into the clipping plane, you might want to reduce that. And then also you've got this facing, where you've got front, back, or both, and this is the direction that the HDR faces in the viewport. So you can set it to the front, the back, or both if you want, just so it's where you want it to be. Okay, so I'm going to set it to both, and let's move back to look at the render as it's going through. Okay, so that's now finished, and you can see we're getting really nice results. Still a little bit noisy, but if we remember from our render settings, everything is down low, especially quite a lot of this noise in the glossy areas where we've got only a single sample. So just so we can see exactly what this is looking like, I'm going to do one more render where I'm going to increase my diffuse and glossy to both 2 and then up my anti-aliasing. I'm also going to come back to my sky dome, and I think it's still a little bit too dark, so I'm going to just make sure that I increase the intensity maybe to 2.5. and we'll let this run through again. Okay, so that's now rendered out, and you can see we're getting a really nice image. Everything's looking pretty good. We may choose to up the samples in some areas, but generally we're getting a not too bad result just with the low samples we've got at the moment. So let's just save this scene out so you have it. And I'm just going to go with 03, and we'll call this Sky Dome. I'm going to take the Sky Dome light, and we're just going to get rid of that. And what we're going to do now is we're going to move on to looking at the mesh lights. So mesh light is really interesting. It basically enables you to have a piece of geometry that actually casts light into the scene. So let's just go ahead and create something. So I'm going to go with, just say, a straightforward torus. Just go across to say this view, and let's draw it out maybe somewhere here, maybe about this size. And we're going to spin it round, and we're just going to have it visible in the scene. So maybe somewhere there. Let's make sure these are set to 90 and move it up. So this is going to be what's going to be casting the light into the scene. So let's just move back to our camera. There it is. I'm going to maybe move it just so it's kind of here out to the side just a little bit, so we can still see our main character. Maybe we just bump it back just a tad so it's not covering too much of the scene. Now we've got this, we basically come over to the Arnold menu and we come to lights, and we now choose mesh light. And what this does is it converts the geometry, or adds to the geometry, the ability now for it to cast this light into the scene. Now in reality what happens is that we go from this poly mesh here under the Arnold tab of the poly torus shape into the mesh light, and then we get all of our mesh light controls here. And you can see they're very similar to everything else. You basically got decay types, samples, you've got all of the information on color, temperature, everything like that. So we're going to go with, just say, a exposure of 1. Let's use our color temperature again, and maybe keep it around the value that we have at 6500. And let's just go ahead and do an IPR render. You can see now we're getting quite a nice distribution of light. And if we wanted to, we could come up obviously to the exposure and just go ahead and maybe make that a slightly higher number. 3, could even try 5. Maybe a little bit hot, but not too bad. Okay, so I'm just going to close this down, and there's a few things in here that we just need to be aware of. Firstly, we have this visible light setting here. This basically says when it's on, I go back to my IPR, you're going to see the light source. Okay, so when that's switched on, you see the light source. When this is switched off, the light source is going to disappear. Okay, so there it goes, having been switched off. So that's one thing to note there. I'm going to leave it on because often you might want to do that. The other thing is a little bit further down, you've got this subdivision option here. And this enables you to subdivide the mesh, and I can choose the kind of subdivisions you want. So if I just open up this, so if I just pause this and then open this up, you can see I've got Catmull Clark, or I've got linear, and then we can increase the iterations. Now this obviously is used for doing subdivision surface itself on the mesh, but you also may want to use this if you find that you are getting some kind of blurriness in reflections of your mesh light. Okay, so basically if you find that you're getting some specular reflections that don't look as good as you think they should be, they're not clearly visible. So an example could be if your mesh light was, say, a TV screen, and you wanted the TV screen to be reflected in a mirror or another object, you might want to come in and just increase this iterations here. Okay, so that's one really useful thing. The rest of this we'll talk about later on when we get into talking about subdivisions themselves. Okay, now there's a big quality difference between whether you have a mesh light or whether you have a mesh that emits light into the scene using just a standard AI shader. So let me show you the difference. I'm going to render this mesh light with a AA of 4, everything else as 2, and then the mesh light itself, I'm going to set the samples to 2 as well. So I'm going to render this through, and then I will take the mesh light and basically say it's a normal light, apply some material to it, and emit light using the emitter option, and then you'll be able to see the difference in quality, because there's quite a big difference in kind of noise and just how things look. So we'll let this render through, and then I'll set up the other scene in the background and then show you the outcome of both of those results. Okay, so those two renders are finished. So this is the render where the torus is actually generating light itself. It's actually a mesh light, just as we were seeing earlier. You can see we're getting a really nice image. It took about 2 minutes 40 to render, and we had AAs of 4 and then diffuse and glossy at 2. This, however, is the image with exactly the same settings. You can see that it took 20 seconds quicker to render, but here the light is actually a normal mesh with an AI standard with the emissions set to a scale of 2.5. So you can see there's a dramatic difference in whether you use a mesh light or whether you simply emit light from a normal surface. Okay, so that's your mesh light. You've got full GI taking place, there's hardly any noise there, and then here you don't have so much GI taking place, or any I believe, and then you obviously have a much noisier image. Okay, so that's the mesh light. Okay, so finally we have all of our filters. We have decay, light blocker, gobo and barn doors. So let's very quickly look at these before we're completely out of time. So I'm going to make a light. I'm just going to make a spotlight because this is the one that has the most freedom to add these various filters in. I'm just going to swing this around and let's just put this up here. Maybe somewhere like that would be good. I'm just going to take my cone angle maybe down to 25. My decay region, or penumbra rather, up to say 20 or 15, maybe 15 is fine. Under Arnold, I'm going to increase my exposure to maybe 7.5 and my samples to 2 and my radius to 0.75. These are just numbers that feel like they could be a good starting point. So let's go back to my camera and let's just take a render of this with the IPR so we can see what we're getting. Okay, so not too bad. May need a little bit more light. So let's just cancel that and maybe increase my exposure up to 8.5 or 10. Maybe 10 and rerun the IPR. Okay, so plenty of light for us to see what we're doing. So again, I'm just going to stop that. So we're just going to come down to the bottom of that Arnold section and you'll see there's this filter menu here, light filters. And when we click add, you can see we have gobo, barn doors, light blocker and decay. So let's just go with decay first of all. So we grab decay, double click on it, which opens up that section in the attribute editor. You've now got a near attenuation and far attenuation. So if we again just run our IPR up, give it a moment to update, and we'll just check our render settings, see what we're getting there. See if we can reduce these down a little bit to speed things up. So pretty low already, so I'm just going to leave them where they are. So I'm going to switch on use far attenuation, and at the moment the whole thing just goes black, and that's because we're basically saying the attenuation starts at 0 and finishes at 0. Well, let's start it at 0 but finish it at maybe 5. What you're now going to see is the light attenuating from 0 to 5 through the scene. And sometimes we need to restart the IPR just to make sure that it's happy with the changes we've made if we make something quite drastic. If we're not seeing anything, then we've clearly done something wrong. So let's try saying start the attenuation at 1 and let's see how far we need to push this up. 50 is way too much, clearly. 10. So with 10 you can see the attenuation is falling off, just getting a bit of the chair, just getting a bit of his head. If we were to increase this even more, so maybe 8, just getting the top of his hat, just very briefly. We could also say we actually don't want the attenuation to start until 10, but we want it to finish by, say, 15. So everything above 10, from the light's point of view, is going to be completely illuminated correctly based on the light's fall off. But then from the unit of 10 down to 15, the light will then begin to fall off or attenuate. And obviously you can make this number anything you want for the kind of an effect you want to get. So it's just a way of controlling the light fall off. Okay, so that is attenuation. So let's again drop back to the light. And I'm just going to disconnect that. Let's add a new one. This time, let's go with a light blocker. Now the light blocker actually makes physically a box in the scene, and anything this box is basically covering gets the light blocker kind of working with it. So if we don't want this chair to be illuminated, we basically cover it with the light blocker. So if we just go across to the perspective view, let's increase this up in size. Fit it over our chair. So we'll have it just off the ground. So the legs are still there, but the rest of it is being blocked. I'll tell you what, we'll bring it down like this, so just kind of the middle section of the chair is being blocked by the light. Okay, so now if we come back to our camera, call up the IPR again. At the moment you'll notice that there's really nothing visible happening in the scene. But if we now begin to increase the density, you'll notice now that the chair is beginning to get the light blocked from it. And if we go all the way up to 1, we've now blocked all of that light. Okay, now we're getting quite a hard edge here at the bottom, so we can begin to make changes. So let's say that we want to use the Y. We can then add a kind of a ramp to smooth that. So you can see now we've added this kind of smoothing into the Y-axis of that position. You can also round the box down. You can adjust the height, edge and width and things like that. You can also choose different shapes. So if I just move my IPR off for a moment, I can come with, say, not only a box, but I could also choose, for instance, a sphere. And again, this can be scaled. Let's move it over our main character and scale it up a little bit. So you can get that kind of effect. I've even got it partly over his eyes, so let's just put it all there. Again, just get some kind of a view. Again, if I render this time not on IPR but just on the normal renderer, you'll be able to see again that sphere shape, and we could also choose just a straightforward plane or a cylinder. Okay, so you can see that's covering him and we're getting that kind of blocking of the light. Okay, so that's the light blocker, can be really useful. I'm going to turn it back to a box, and again you can see that over him. So let's come back to our spotlight, get rid of the light blocker. Next up we have the barn doors, and we're not going to spend much time on these because they're pretty straightforward, just like any other barn doors. You basically got the top left, top right and edge, and then the bottom left and right for each one of those. So basically the top left moves the left corner of the top flap of the face of the light. The top right moves the right corner of the top flap, and the top edge controls the edge softness overall. So if we were to again call up our IPR, let's come to our top and let's just make an adjustment with that. You can see as we pull these in, we're basically blocking the light. So let's go with 0.25 for both. You can see we've now cut that off with the barn door, and if we then wanted to feather that, we could do that. So you can see now I've added a slight bit of feather into that. Okay, so that is your barn doors. As simple as that, very straightforward for normal work. So again, I'm just going to close down the render. Let's get rid of our light blocker. Also just delete our barn doors, and we'll add our last one, which is our gobo. So we double click. And what a gobo does, it's obviously like a kind of a filter or kind of mat that goes over the light to give some nice effects. So let's, for instance, say that the slide map or texture we're going to use is going to be just an Arnold texture file. And let's go with one that I prepared, which is just a straightforward kind of set of trees. So it's like black and white trees. So say OK to that, and let's just render that so you can see what that looks like. So you can see there we're getting that nice pattern of trees on the floor based on that kind of gobo that we've dropped in there. Now, some of the options that I've got include the ability to blend. I can also do things like replace. I can add. I can do things like sub it. So we kind of do a sub or a mix. So I tend to find that something like blend is quite a nice starting place. You then have density, and basically this controls the density of the gobo. Higher values make the gobo more opaque, and therefore it lets less light through. So if I make it 0.5, the scene gets darker as less light gets through the gobo. So again, just put that back to 0. You then have offset, and this is basically UV coordinate values used to offset the direction of the texture map. So you could do that if you wanted to move it around. You've got scale S and T here, and what they do is they scale the texture used for the slide map in the S direction and scale it in the T direction. Then you've got underneath scale S and T, the warp S and T, and you can basically determine what happens to it. So basically the periodic says that it repeats itself outside the 0 to 1 range in the S and S or T space. You can set it to mirror, that obviously mirrors the image across the boundaries. You can set it to file, which uses the wrap mode found in the file if you have one there. You can use clamp, and clamps the image to the closest image edge, or you can use black, which basically just kind of chops it off. So obviously usually the best one to use would be either periodic or maybe mirror. So again, if I scale this down 0.05, you'll see that we're getting that kind of scaling taking place, and now the wrap's working based on the periodic as opposed to our original setup. So that is the gobo. So it's very straightforward to use, as you can see. So that pretty much now takes us to the end of the class. We've probably gone over a little bit in time. Any questions that you have, please put them in the forums. We will continue obviously to look at lights as we go through, but this was really kind of a whistle-stop tour of all the main features in the lights, just so that you could get yourself going and hopefully get a good understanding as to how all the controls work, both the Arnold ones and the ones that are left over in the Maya setup as well, that we can use as part of the Arnold renderer. So until next week, as always, this has been Matt Leonard for FX PhD.